Three masses are stacked on top of each other and are resting on the floor. Determine the net force acting on the 3 kilogram mass. So these objects are standing still and there is no acceleration, therefore there is no net force. It means 0 Newton. 0 Newton is the answer. A car mass M makes a turn with a radius r. The coefficient of friction between the tires and the road is mu. The maximum speed that the car can make the turn without skidding is velocity. If the mass of the car is doubled, what is the new maximum speed? So the mass is doubled, then what about velocity? The central force is the sum of the forces acting on the mass and direction toward the center of the circular motion. The centripetal force. For a car making a turn, the force acting toward the center of the turn is friction. So the central force is equal to the friction force. This is the friction force, and this normal force is being applied to this equation. So this is cancel out. Oh, there, yes, this is cancel out. So friction force, coefficient of friction force, and this is the equation that we can find, but there is no mass. In this equation, mass is not involved, so mass does not affect the outcome. It's not part of the equation, so velocity is still velocity. A 2 kilogram mass is pulled up a sorry inclined at a constant speed of 0.5 meter per second. Determine the force required to move up the incline at constant speed. Determine the power required to move the mass up the incline at constant speed. Determine the work done by force to move the mass to a vertical height of 2 meters. So this is a object on the inclined plane. This is 30 degrees. This is 2 kilograms. So you can find the free body diagram, and this is and this is and we are going to find this, then So this is the first is gonna be 10 Newton, and you can find the work. Work is force multiplied distance, and this is gravitational potential energy. We can apply this to this equation. Then this is going to be 40 joules. And we can find power by using this equation. So this is 5 watt. So this is the answer of first question, and the 40 joule is gonna be the answer of third question, and this is second question's answer. 5 watt is the second question's answer. Determine the acceleration of gravity in terms of g at a point in space that is located at a distance equal to 2 Earth radii above the surface of the Earth. So this is about orbital involved circular motion. The centripetal force is the sum of the forces acting on the mass and directed toward the center of the circular motion. For planets, this is the force of gravity. Since the mass of the orbital body cancels, or planets at the same radius will have the same orbital speeds. Two cars with masses 3m and m are placed on a horizontal track with a compressed spring position between them. The cars are released from rest. The 3m cart moves to the left with the speed of velocity. What is the speed of the cart on the right? So there is two carts, and one of them has mass of 3, and the other has mass m, and they are connected with a spring. Also, the momentum of the two objects are in opposite direction. Their magnitude must be equal to conserve momentum. So this is the equation of momentum, and we are following the conservation of momentum. So this is the speed of the cart on the right. A satellite of mass m orbits Earth at a higher of h and a speed of velocity. What would the speed be for a satellite of mass 3m at a height of h? So this is the Earth, and this is satellite. This is height from the Earth, and this is moving by velocity, by this velocity, and this mass gonna be equal, and this is 3m. This is just mass m. So we are going to find the momentum. So 3 velocity, this is the answer. The object of mass m is pulled to the right at constant velocity along a rough horizontal surface by a string. The tension in the string has a magnitude and is directed at an angle as measured from the horizontal. Determine the magnitude of the friction force. Determine the relationship between the magnitude of the normal force and weight of the object W. Object weight. So this is the mass m object, and this is going to be force of tension, and this is the angle, and the force to the x direction gonna be normal force multiplying cosine, and this is equal to friction force, and force to the y direction, and we can find this equation. The force of friction must be equal but opposite to the horizontal components of the force to the x direction in order to maintain constant velocity. The normal force is less than the weight of the object because the string is lifting the object by an amount equal to force of tension sine theta. So this is force of tension. So we can find this equation, and this is mean the normal force is less than weight. So this is one of the answer of the question, and this is the answer of second question. A car completes a turn that has a radius of 2 meters. The coefficient of friction between the tires and road is 0.50. What maximum speed can the car safely maintain in order to complete the turn without skidding? The friction force holds the car in the turn and creates the net centripetal force, acting toward the center to the circular motion. So this is the centripetal force. This is friction force. So we are going to find this equation. So the mass is cancelled out, and so 10 meters per second is the answer. The mass m is uniform circular motion with a speed, velocity, and a radius. How is the centripetal acceleration affected if the radius is doubled while the speed remains constant? So this is the force. And this is going to cancel. This I is replaced to the 2r, and this means the centripetal acceleration is going to be 1/2. A mass m of 3 kg is removed from rest on a surface that forms a quarter circle with a radius of 0.80. When it reaches the bottom of the circular portion, the track is horizontal for a distance of 1.2 meters. All surfaces are smooth and frictionless. Determine the speed of mass when it reaches the end of the horizontal section of track. The potential energy at the top of the curved section of track is transformed into kinetic energy. The initial height is equal to the radius of the curved section of track. So the height is radius. Height is equal to radius. So this is potential energy, and this is gonna be kinetic energy. So this is 4 meters per second, and